Hello everyone. In the previous episode we looked at the block and schematic diagram of the 909 snare, and in this episode we are going to put the module together and have a listen to it. So, with the schematic diagram completed and the cross-checked against both the hex inverter 909 and the 9090 design, the next step is to start working on the PCB. The Eurorack form factor is 8 HP, which is the same as for the 909 kick. I'm trying to place the jacks and pots on the same positions so the module doesn't look too different side by side. This is also a pretty dense design. The part count is roughly the same as for the kick drum. The PCB layout design is quite labor intensive and can sometimes be a bit frustrating when you have to move around parts and redraw complete areas to fit one single trace. I plan to make a detailed tutorial series on my Eurorack module design process from start to finish, featuring the 909 rimshot, so stay tuned for that if that is something that you are interested in. Anyway, after the PCB design is completed, checked and the PCBs are ordered, it's time to source the components. And when the PCB finally arrive, it's time to solder the prototype together and test it. In the first version of the PCB, I added a LED, but it turned out that it didn't work as intended. So I removed it because I figured that I didn't really need it. The design was tested and I used a 3D printed panel to check the placement and the dimensions of the hole for the trig button on the front. After that I made a couple of small changes to the PCB, so I made a second board spin. So, it's back to the soldering station again and assembling two modules. One with the through-hole ZTX1051A and the second with the MMBT5089L SMT part. I haven't made up my mind which one I like the most, so I think that I will have to build both and compare them side by side. So while I'm working in the background with hand soldering roughly 120 SMT parts, let's go back to our old friend, the noise module. I made the decision to have individual noise circuits for all my modules that is connected to noise source. So I made a piggyback module that I can reuse for all my modules. And since I will need a total of 4 noise boards for all the 909 voices, it makes sense to order a set of pre-assembled boards. I will quickly show you how to order that from JLC PCB. First, go to my GitHub and grab the files for the noise module. Then go to JLC PCB website and click Order Now. Add Gerber files and choose PCB color and the option that you like. Select PCB assembly and select tooling holes added by JLC PCB. Click Add BOM file and select the file noise_brd_bom version 1. Click Add CPL file and select the file noise_brd_positions version 1. Select the usage description and click Next. Review the component list and click Next. Now you can review the component placement. Everything should look okay, but if there are any issues, an engineer from JLC PCB will correct it for you. The total ends up around €25, which is a pretty good price for 5 pre-assembled PCBs. If you have ordered from a JLC PCB before and have SMT coupons, make sure that you use those to get the price down even further. Okay, let's see if our production personnel have finished the board yet. Well, it's almost completed with SMD parts. From now on, all my new designs on GitHub will include an interactive BOM. This makes a dense board like this much easier to assemble. With all the SMT components in place, next step is to solder all the through-hole components on the component side. After that, we can continue with the top side with all the jacks, pots and the Cherry MX button. Alright, with both modules finished, it's time to listen to them. tones sound a bit different. The through-hole version have more distinctive noise, and I think I prefer that one. For the next demo I'm using a setup with a MIDI trigger module controlled by a drum track made in Ableton. And that's it. I hope you have enjoyed this video and find it useful. Thank you for watching, and I'll see you in the next episode. Goodbye.